Now that we've talked about what a regular transformation is, we are now going to talk about what a reflection is specifically. So just a reminder, a transformation is an operation that maps the original figure, called the pre-image, onto the new figure that's called the image. A transformation can change the size, position, or shape of a figure. Remember that our rigid motion transformations do not change the size of our figure. It'll still be the same shape and just a different position. All right, so for our reflection in our picture, remember we can tell if it is the pre-image or the image by the markings with these little letters. So this one on the left is our pre-image, and the one on the right is the image. For a reflection, it's a flip over a line called the line of reflection. Each point and its image are going to be the same distance from the line of reflection. So a couple possibilities of what you could reflect it over would be the x-axis or the y-axis. We could have some horizontal or vertical lines, and remember your vertical lines are x equals a number, and your horizontal lines are y equals a number, so make sure you can tell which is which. The diagonal lines could be y equals x, which remember is our parent function for a linear function, or it could also be y equals negative x, so it would be the slope of a -1. So what we're going to do in number 1 is we need to graph and label each figure and its image under the given reflection. So first off, we need to graph the original coordinates. Then we need to know where that line of reflection will be, and then this one is the x-axis. I'm going to do that in pink across so we can see where our line of reflection is. That means that all of these coordinates are going to flip over this line. So if you folded your paper in half along the line of reflection, my B would be the furthest away, the C would be the closest, and then A would be kind of the medium distance away from each other. So what you need to do is we need to count the spaces away. So my C is only one space away. Above, that means when I flip it over, it's going to be one space below. So that's my C prime. Next, I can count the spaces away for A, and that is 2 spaces above. So now when I flip it over, it'll be 2 spaces below. Then for the last one, we have our point B up here, and this is 7 spaces above, so it will be 7 spaces below my line. And that makes my B prime a 4, -7. So when we connect these together, there is my image, and the ones in purple are my pre-image, so the original coordinates. Now for the number 2, the only switch is now it will be against the y-axis. So go ahead and graph your coordinates first. We know that the y-axis is going up and down, so here's my line of reflection. And then for our image, we know that all these coordinates are going to flip over to the left side. So I can see that my point P is only 1 space away, so here will be my P prime. My Q is only 2 spaces away from my line, so here will be my Q prime. Next, let's do the point S. So point S is 7 spaces away to the right, so it needs to be 7 spaces away to the left side, and that would be our S prime. And the R is 8 spaces away from my y-axis, so it would be 8 spaces away to the left on the other side. So you have to remember the biggest thing is that your x-axis is horizontal, y-axis is your vertical line, and then you're just counting the spaces away, so the number of boxes that it takes to get to that line of reflection, and then count it on the exact other side, and that'll tell you where your next coordinate will be. We did skip over the last 2 questions, but you can use those to go back and practice those other type of questions. So here we're going to do number 5. So we first need to graph our pre-image coordinates and graph your line of reflection. Now remember, your line of reflection is a vertical line because it is x equals a number, so it's going through at 4 and it's vertically up and down. So try to get your line as straight as possible along that line so that it's easier to count your spaces. So the same process works as if this was the y-axis, and we need to count the spaces away from our coordinates directly to that line, so perpendicular to my line of reflection. So my point K right here is 2 boxes away, so that means that I know my point K will be 2 boxes, or K prime will be 2 boxes away on the other side. Now the part that might get a little tricky is that you need to make sure you actually count your coordinate for point K. So my point K is going to be at 6 and then 3. Point L then is one space away on the left, so it needs L prime needs to be one space away on the right. And if we count out where that coordinate is, I want you now to fill in what's your coordinate be for the L prime. What you should have chosen then was a 5, -2 for the coordinate. So I want you to do the same thing now for letter J prime. I'm not going to draw it for you, so you need to find where that coordinate is going to end up on your graph. When you counted it over, it was 3 spaces away on the left, so now it's 3 spaces away on the right, and that would make it at 7, -1. Now we're going down to number 7 because now we have a horizontal line for y equals 2. So remember, we need to find where the y-axis is and then the 2. So make sure you draw your line a little straighter than mine went. And same idea, except now we're going up and down. So my point E prime would be 1 space away up above. My point F is 5 spaces away below, so now it's 5 spaces away up above. My point D, that one's a little bit easier, that's only 2 spaces away, so D prime will be right there. Point C prime then is C is 6 spaces below my pink line, so my C prime will be 6 spaces above my pink line, so that'll be way at the top. And there are the coordinates of those new coordinates. Moving down to number 9, you can see that I sort of have my pink line drawn already. So y equals x means that we have a slope of 1 and the y-intercept is 0. So now you want to connect those points together. So what we need to do is figure out how many spaces away are each of our purple points going to be from that pink line. Okay, so here's what you need to do. If we look at point x, if you count diagonally, there's 1 full box and then a half of a box. So that means on the exact other side, if we keep going diagonally like that, it's going to be half a box there and then 1 full box. So this is where our point x prime will end up. Point Z will be the same way. So this one's a little bit easier. There's only 1 box diagonally to follow. So 1 box diagonally on the other side. This is where my point Z prime will end up. For the point Y, we might overlap a little bit. So there's 1, 2, 3 full boxes and then a half of a box. So the half of the box to finish that out, 1, 2, 3 full boxes. So here is where our y prime will end up, and that is at 4, -3. A way you can check your answer is you could always actually fold your paper along this pink line, and each of these points should line up right on top of each other if you hold it up to the light. All right, so we've got one more we're going to do, and that's this number 12. So we can have y equals -x. The only difference there is instead of a positive slope, our slope will be a negative slope. So now if you connect your points together for the pink points on there for our line of reflection, we can see that the point U is only a half a box away. So a half box away on the other side would be right here for our U prime. Go ahead and fill in what the coordinate should be for U prime. U prime should be 4, -3. All right, so I want you now to move the point T across to find what the coordinate is of T prime. When you do that, you should get 3, 0, and that's because we have 1 full box diagonally and then a half a little box. So we have a half a box and then 1 full box. So right here is our T prime. Lastly, we have our S, so just be careful going across there since we're going through the triangle. So we have 1 full box, 2 full boxes, 3, and then half. So there's the other half, and then we have 1, 2, 3, and there is our S prime, and that is at 6, 1. So then don't forget to go back and connect your coordinates together to show where that image is at.